All right, let's find the inverse of g of x equal to 4 all over x plus 9 plus 1. And then we're going to find the domain and range of both the original and the inverse. So when we're finding an inverse, we always have the same 4 steps. First step, replace g of x with y. So we're going to have y is equal to 4 all over x plus 9 plus 1. Step 2 says that we switch, interchange x and y. So instead of y equals, we're going to have x is equal to 4 all over y plus 9 instead of x plus 9 plus 1. Okay. All right. Third step says that we need to solve this equation for y. And I know that you're thinking, hey, we can just multiply by that denominator. But if you do that, you need to multiply the 1 by the denominator as well. It's just going to get a little bit icky. So instead, I highly suggest that we subtract the 1 from both sides. We get x minus 1 is equal to 4 all over y plus 9. And now we can look at the x minus 1 as a group. And when we multiply by the y plus 9 on both sides, we get y plus 9 times x minus 1 is equal to 4. Because on the left-hand side, it stays, but on the right-hand side, the y plus 9 cancels out. And I know you're thinking, I don't want to distribute and FOIL this. Okay, so let's not. Notice that we have y plus 9 in parentheses times x minus 1. The opposite of multiplication is division. So we are going to divide both sides of our equation by x minus 1. In doing so, our y plus 9 stays the same. The x minus 1's cancel out. And we get 4 all over x minus 1. We're going to subtract 9 from both sides. So we're going to have y is equal to 4 all over x minus 1 minus 9. Notice that the 9 stays big. It's not part of the fraction. Okay. And then our last step, we need to put in our inverse notation. Because we started with g, we're going to have g inverse is equal to 4 all over x minus 1 minus 9. And because they had given us the original function with that plus 1 at the end, we don't have to combine this all into one giant fraction. We can have that minus 9 hanging out on the outside. We still need to do domain and range. Because we need to do domain and range, I'm going to go ahead and create my chart to keep everything nice and orderly. So my first row will be domain, second row will be range, and then my columns are going to be for my two functions. I'm going to have my original, g of x, and I'm going to have my inverse, which was g inverse of x. Let's start by finding the domain of g of x. We're going to take the denominator, set it equal to 0 to find our restricted values. We're going to take the x plus 9, set it equal to 0. We don't have to worry about the plus 1 because it doesn't have a variable. We're concerned about that denominator because if it were to equal 0, we would get an undefined and life would just come crashing down around us as we know it. If we solve this equation, we get x equal to -9, which we know is our restricted value. Our restricted value is what we cannot include in the domain. If I'm looking at my number line, which goes from negative infinity to positive infinity, negative 9 is my one restricted value, so it cannot be negative 9. Let's go ahead and write our domain in interval notation. First step, we're going to have negative infinity to negative 9, parentheses around everything because we will not hit infinity and we cannot include negative 9. That's what made us undefined, the denominator equal to 0. We're going to hop over negative 9 using that union sign, and then we're going to have negative 9 to infinity for our second interval. We just found the domain of g of x, went from negative infinity on up to negative 9, union, negative 9 to infinity. Because we found the domain of the original, we found the range of the inverse, which means that the range of g inverse is going to be negative infinity to negative 9, union negative 9 to positive infinity. Almost done. One more thing that we need to find. We need to find the domain of the inverse. And our inverse function was also a rational function. If we look at it, it's 4 all over x minus 1 minus 9. We need to take that denominator, set it equal to 0 to find our restricted value. We find out that x is equal to 1 is our restricted value, which means that we cannot include 1 in our domain. If we were to include 1 in our domain, we would have an undefined piece going on for our function, and that's just not cool. So looking for our interval notation, we're going to have negative infinity on up to 1. Again, parentheses everywhere. Need to jump over 1, which means we need the jump rope, the union sign. And then our second half, we're going to have 1 to infinity. You can have multiple restricted values. Remember that the number of pieces in your interval is always going to be 1 more than your number of restricted values. And since we keep finding 1 restricted value for each domain, we have 2 pieces to the interval notation for our domain. Since we found the domain of the inverse, we found the range of the original. So our range for the original g of x is going to be negative infinity on up to 1, union 1 on up to infinity, just like the domain of the inverse.